Thanks. So we started our FreeMind / BARDA journey about 3 years ago. We were at this very conference, and we kind of, based on press releases, we saw what BARDA was investing in, what their interest was, and we thought, hey, we have a platform that we think is as good or better than the state of the art. So we started the process then. So first, I'll just quickly show you what our platform is. We consider it next generation because it's tiny, very low cost, it's fast, it has a broad assay capability. We can look at 33 targets in this one genomic detection instrument. We can handle a variety of sample types, and it can be used, obviously, it can be used in the field. So I'll skip some of the company pitch stuff and focus a little more on the BARDA stuff, but we really saw this opportunity. We originally were working on tuberculosis, which has a requirement for extremely high sensitivity. And if you want to have an impact on global health, you have to be able to have a mobile platform also. So what that led us to do was develop a system that had extremely high sensitivity, and that also led us to work on sepsis, or bloodstream infections, which is the cause of most sepsis. So that led us also to being able to do any other bloodstream type infections, and it also taught us how to handle large samples of blood, which no platforms right now can do very well. So if you look at what I consider this sort of Venn diagram of the molecular diagnostic space, there's lots of fast platforms, but they tend to be single tube assays. They're great for what they do, but you can't look at a wide variety of targets. You tend to need tens of thousands of organisms to do a positive detection. You have a lot of broad-based platforms, which is really what you want, symptom-based diagnostics, because of course you're doing the test because you don't know what the patient has. So we wanted to do a broad panel, and there are some platforms that do that, but they don't have the sensitivity. So really, until you combine sensitivity, speed, and a broad panel, that's when you can really tackle bloodstream infections. So the speed advantage is dramatic. The state of care right now for a bloodstream infection is they put your blood in a culture bottle and you wait. The data isn't really strong on this, or it's hard to determine, but it's thought that something like half of bloodstream infections never even culture for various reasons. So there's even sensitivity issues with that, but mortality is very high. It's not as bad as something like anthrax in terms of the speed at which a bloodstream infection can kill you, but your mortality increases by about 8% per hour. So speed is the most important thing once you're sensitive enough to get the test done. But as you can see, nothing is even close to being able to do this in an hour, and that's what Tangen can do. So what we did is we developed 3 separate technologies, all very specific to solve this specific problem, which is you have to concentrate the sample. Nobody else really concentrates the sample. Typical PCR assays, they actually dilute the sample to make it PCRable, to get rid of the inhibitors. But if you want to detect one bacterium in, say, a few mils of blood, you have to figure out how to concentrate the sample. So we figured out how to do that. It's a very simple process, takes a couple of minutes. They're doing that right now as I speak in the pilot testing sites that are running the assay. We developed a broad panel assay, so we could look at up to 33 targets at once. So we can look at different organisms. We could look at mutations of different organisms. We can look at genes, such as drug resistance genes. And so that's a powerful tool because of that. And of course, the instrument, being a light deployable instrument, makes everything a lot more efficient and useful. So this is kind of an outline of how the BARDA process went. We responded to the Tech Watch, which I think we looked at their website and we asked for a Tech Watch and a meeting. We got the meeting, I guess it took a few months. We got the meeting in November 2015, and I have to say, anyone who's in a small company trying to raise money, when you're a technology company, it's challenging for the investors to understand your technology, to get all the experts in the room to know, is this thing going to be real? Is this a team that can do that? And I have to say, BARDA was the best equipped to do that. We sat in a room with 5 or 6 people who all designed instruments. They knew all about all the technologies, and that's why I think we felt like we were going to have a good relationship, because they really understood what we were doing, how we were doing it, why we were doing it the way we were doing it, and I think they valued that. So we continue to work with them. We submitted the first stage, a white paper. It's a fairly short paper with a quad chart. So that happened almost a year or so later. They reviewed that. They asked for some revisions to that. So most of this, after the first meeting, it was mostly communication by email. Once we got the second white paper submitted, they asked for the full proposal, which is a pretty big project with FreeMind was extremely helpful with. It's something like, 70, 80, 90 pages. It was a big project for all of us, myself and the co-founder and our clinical people, to really put that all together. And BARDA's, one of their big concerns is that, okay, a lot of people have great technology ideas, but can this team put it together, get it through the FDA, get it manufactured? Do we have the right partners? So their process kind of forced us to look around for manufacturing partners probably earlier than we would have, but it was a good thing to do. So we have people now already manufacturing our assay for us, and that was really important to them to make sure this is manufacturable. You're going to meet your cost goals, you're going to meet your performance goals. So we felt that benefited us also. So it was just September when we finally entered the negotiation phase, and at that point they asked us to do a little bit more with the feasibility study. They wanted us to look at different bacteria. So we originally submitted for anthrax, but they want us to do some studies on detecting drug resistance genes and also other various bacteria that can be infecting blood, which was, we're happy to do that. So we added that to the contract. It gives us a lot more options for both BARDA and us going forward, because it's not, even though BARDA, of course, is interested in their anthrax, and that's a congressional mandate to do that. There's lots of other bugs out there that we're all concerned about, and a rapid point-of-care assay would be great for a lot of those. So the contract was signed in the beginning of October, and we've been doing it, and they're good partners to have. They meet with us every 2 weeks. We have a phone call. They go over all the deliverables. It's a fairly detailed contract, but it's good. It keeps us, everyone always knows what we're doing and that we're on track and what the results are. So it's been a very good experience for us, and it also gave us a lot of credibility with investors, which is really helpful. Again, you're talking to investors who don't understand the science or the engineering as well as you understand your own technologies. So that's been helpful also. And this is just a photograph of the slide from, I guess it was Industry Day in October or November, but we're in pretty good company up there. It's Tangen and 2 other platforms. Those platforms were funded before they were bought by the large acquirers, which is, I think normally BARDA is just funding the smaller companies, but that's why they're there. And that's it. Any questions? Yes?
Quad charts from BARDA. What does a BARDA quad chart look like?
I can send you a copy of ours if you'd like to see it. It's a very specific chart that shows how your technology sort of fits into the big picture. But we did that 3 years ago, so 2 years ago. But we're happy to send you a copy of that if you like. You can go online and you can Google quad chart and it'll tell you what they're looking for. It's fairly simple. Yes?
So are you looking at any other disease indications besides sepsis?
So right now we're doing the commercial product right now is a fungal sepsis panel. That's a subset of what blood infections could be, but that's a very narrow cohort of patients, and that's why we went after that one. It's also a little bit easier. There's only five fungal organisms cover over 90% of what they might have. Bacteria, it's like 16 or 19. So we developed a TB assay. We worked with Gates on and off on that. We had just got some small funding for that. We've done a few different bacteria as proof of concept. We've done E. coli and staph just to show that we can capture it, we can break it open, we can detect it. And we have some various other larger companies asking us to do specific assays for them that I can't really talk about. But this device is essentially a generic DNA detector, and the primer sets, it's isothermal, the primer sets are on this plastic disc. So what the machine does, it blows up the cells and it puts the DNA onto the disc, and then we try to figure out what it is. So the machine is very generic, so there's not too many things we can't do. We're just, in terms of if it's living and it has DNA and we can get it into our system, we can detect it. It's just a matter of what is the biggest unmet need or the biggest commercial application for it. Yes?
There's a slide. You have a slide here.
Yep. Everything is now past provisional, so they're all working their way through the PCT. Right now there's four items. So I think they're actually all published at this point, so you could actually find them if you wanted to. Anyone else? All right, it's lunchtime. Thank you.